Hello, this is Jack Jackson. Today we're going to be going over a practice test. This is a test over linear functions and related information. And this particular practice test is practice test 2A from the spring of 2013. And you can use this as a review of this unit and preparation for the exam. We're going to be doing practice test 2A in this video, which is to be done without a calculator. So I will not use a calculator. I have my scratch paper over here on the side, and let's go ahead and get started here on this. Alright, first question. Solve this equation. 4 parentheses x plus 2 equals 7x plus 5. I'm going to simplify each side separately by distributing on the left. 4 times x is 4x. 4 times 2 is 8, so the left side becomes 4x plus 8. I'm going to eliminate the x's from the right side by adding a negative 7x to both sides. That's going to leave me negative 3x on the right. And I'm going to still have the plus 8, so I'm going to get rid of it by subtracting 8 or adding a negative 8 to both sides. And so we get negative 3x equals negative 3. Divide both sides by negative 3 to get those to cancel out, and we get x is 1. Let's go ahead and check it. 4 times 1 plus 2 should be same as 7 times 1 plus 5. This is 7 times 1 is 7 plus 5. 7 plus 5 is 12. 2 plus 1 is 3. 4 times 3 is 12. So that does check. So I feel confident that 12 is my correct answer. And let's go to the next question. Number 2, we have an equation 2x minus 3y equals 6. It's asking us to find the x and y intercepts. So when x is 0, we plug in 0 here for x, and that's 0, and then add that to this, becomes negative 3y. Divide both sides by negative 3, we see y is negative 2. So 0, negative 2 is the, that's going to be on the y-axis, that's the y-intercept. And to find the x-intercept, we let y be 0. And so that's 2x minus 3 times 0 equals 6. That's 0 for this part right here. So we get 2x equals 6. Divide by 2 to get x is 3. So 3, 0 is the x-intercept. Now we want to use the graphing tool to graph this. I can do it straight from here. I can make it a little bit bigger if we want. Let's make it bigger. Okay, and we know from the form that we have here, this is a basic form, ax plus by equals c, where a, b, and c are constants. We know that's a line. So we know the graph is a line. So we click on the linear one, and we want to use the points. I think they want you to use the points that we just found out, the x and y intercepts. So 0, negative 2 is right there, and 3, 0 is right there, and that should be it. So we can save that, and that should be the line. Okay, next question. Okay, number 3. Find the midpoint. Well, to find the midpoint, you take the x-coordinates and average them to find the x-coordinate of the midpoint, and you average the y-coordinates to find the y-coordinate of the midpoint. So, so this part is always built in right here, like that, and we fill in the 4 numbers. So the 2 x's are negative 5 and 10, and the 2 y's are negative 5 and 4. Negative 5 plus 10 is 5, so that's 5 halves, and this is negative 1 half. So there it is in fractions, and in decimals that would be 2.5 and negative 0.5. Now I'm not really sure which way this is going to like it, but I think the best way probably is to go ahead and use fractions. So I'm going to use fractions here, and I'm going to click on this little thing right here that gives me an ordered pair, and then I'm going to type in a fraction. So I'm going to use the fraction button here like this and type in 5 on the top and 2 on the bottom. Then I'm going to put the negative first and then a fraction and put it 1 over 2, and I think this is going to like it. Now I'm going to go ahead and check this whole thing at the end, so if I make any mistakes along the way or it doesn't like the way I put in an answer, we'll go back and kind of clean that up at the end, but hopefully I'll try to be careful and not make any mistakes along the way. So here we have a line, and we want to find the slope of this line. So what you do is you find, we have a graph of the line given, so we want to find two lattice points on the graph. That's a point where it crosses the grid at a corner where you have integer coordinates. And here you have one, looks like it's 0, 6, and another one at 5, negative 3. So that's 5 to the right. So remember, the slope is delta y over delta x, or vertical change over horizontal change. So if we go from this point here on the y-axis first, and then the second one is over here, we're going to the right 5. So that's a delta x of positive 5. But we're going down 9, excuse me, 6, 7, 8, 9. We're going down 9, so that's negative 9 for the that's negative 9 for the delta y, or vertical change. So we're going to enter the slope as negative on the outside and then 9/5. So if you go to the right one, you go down 9/5, not quite 2. Right there. That works out. So the slope is defined. The only way the slope will be undefined is if it's a vertical line. Okay, so negative 9 and then 5. So we use that with a fraction. Notice, just look at the line. We see it going down from left to right, so that is a negative slope. Just double check. Yeah, we have a negative slope, so that's good. Alright, the next one, number 5 here, we have f of 6 equals 7. That means it goes through the point 6, 7. And we have f of 9 equals negative 5. That goes through the point 9, negative 5. And we have a line, and we want to find its slope. Well, again, the slope is delta y over delta x. That's y2 minus y1 over x2 minus x1. Basically, just label one of these x1, y1 in your head if you want, and the other one x2, y2, and then just plug in the formula. So the minuses are built in, and we take the second y, negative 5, minus the first y, which is 7. We take the second x, 9, minus the first x, which is 6. It doesn't really matter which one you take to be the first point and which one the second, but you do have to be consistent. So if the 5 goes first, negative 5 goes first in the top, the x that goes with it, the 9, has to go first in the bottom. See, this one's a 6, this one's a 9. Okay, so negative 5 minus 7, that's negative 12. 9 minus 6 is 3. Negative 12 divided by 3 is negative 4. Just kind of double checking everything as I go along here. Okay, I believe that's correct. So the slope is defined. It's negative 4. You'd have undefined slope if it was a vertical line, and that would happen if you have, well, it wouldn't happen if it was a function. So function notation kind of gives it away that it's not going to be undefined. But it'd be a vertical line, and you'd have x values the same. So when you have this line, which is y equals 2.2x minus 7, we see that's in the form y equals mx plus y sub 0. And from this, we can clearly see that the slope is 2.2, and the y-intercept is 0, negative 7. This one, they're just wanting to know the slope. Okay, find the slope and then graph it. Okay. So we're just going to graph a line here. This is number 7. Okay, we have 2x plus 3y equals 12. Well, how do we get it in this form up here that we have for the slope y-intercept form or slope-intercept form? So in other words, solve for y. We're going to subtract 2x from both sides. 3y equals negative 2x plus 12, and divide by 3. And I'm going to go ahead and distribute the 3 when I divide here. So negative 2/3 x plus, see, 12 divided by 3, that's 4. So now it's in this form up here. So we see that the slope is negative 2/3. Fraction 2/3. And then we want to graph it. Now it is a line. We know it's in the line. It's a line because, well, among other ways, because we got it in this form here. And so it's a line. So we're going to use the line tool. I'm going to make it a little bit bigger. Choose the line tool. And let's just use what we know here. We know it goes through 0, 4, and the slope is negative 2/3. So 0, 4, let's find that. And then slope is negative 2/3. So one way we can think of that is 3 to the right and 2 down. So 1, 2, 3. Be sure you look at the scale. 1, 2, 3 to the right and 2 down. And that will get it. Notice if we go to the right 1, we're going down 2/3. But we can do a little bit better if we'll get it here. So right 3 down 2 here, right 3 down 2. Yeah, that looks like that's lining up like we want. So let's save that. So let me just double check. Subtract 2x, divide by 3, 4, 0, 4, and slope negative 2/3. Okay, that looks good. Alright, next one. Okay, when we have a y equals a constant, that's a horizontal line, a constant function. It does have a slope. That slope is 0. Remember, there's a big difference between a 0 slope and no slope at all. No slope at all will be the vertical line like this, and 0 slope will be horizontal line here. 2/5. Well, the only one it could possibly be would be the C here, and hopefully that is about 2/5. Yeah, that's about 2/5 between 0 and 1 there, horizontal line. Okay, when you have x equals a constant, that's a vertical line. There's when the slope is undefined. So we'll click on that. Okay, another variation on the theme here. The slope is 5/6, and it goes through the point 7, negative 7. A couple of different ways we can do this. One is we can use the form, the point slope form, y equals m x minus x1 plus y1. That's x1, y1 there. So 5/6 x minus 7 plus negative 7, or just say minus 7 at the end. We should be able to enter it like this. It might like it better. I don't know what the software is going to do, but it might like it better if we put it in slope y-intercept form. So we're going to distribute here 5/6x minus 35/6 minus 7. Get a common denominator by multiplying by 6/6 here. That's 42. Negative 35/6. So y is 5/6x minus 77/6. So it should take either one of these, either that one or this one. Let's see. It says simplify your answer. So I think when they say simplify your answer, I think they're implying that they want it in the slope y-intercept form. So let's go to that form. So 5/6 x minus 77/6. Okay, let me go here and double check all my arithmetic here. So I've got y equals the slope 5/6, x minus the x coordinate plus the y coordinate of the point that we know. So this is the point slope form. They probably want it, because they say simplify your answer, I'm assuming they want that in slope y-intercept form. That's usually considered the simplified form. So we're going to distribute here 5/6x minus 35/6. To get a common denominator to put this together, multiply top and bottom by 6 here, get 42/6. Keep the common denominator, add the numerators, negative 35 plus negative 42. That's negative 77, so that should be correct. Let's go on to the next one. Alright, number 11. Find equation of a line through 2 points. Okay, these are all little variations of the theme here. Well, here's a x1, y1, and let's call this point 2, so that would be x2, y2. First thing we want to do is find the slope, which is delta y over delta x, or y2 minus y1 over x2 minus x1. So, plugging in the numbers, that's 5 minus 4 for delta y of 1, so we're going up 1 from this point to that point. And we have a delta x of 3 minus 1, or 2, so we're going to the right 2. So slope is a half. Again, I can use the slope point slope formula like this. Okay, and I can use either one of the 2 points. Let's just use the first one there. 1/2 x minus 1 plus 4. But it says do it in slope-intercept form, of course, so that means slope y-intercept form. So we distribute 1/2 x minus 1/2 plus 4. Get a common denominator by multiplying the 4 by 2 over 2. So that's 8 halves plus negative 1/2 is 7 halves. And of course we still have to add to that the 1/2 x. And of course that's still equal to y. So that's what we want to put in there. 1/2 x plus, that says, I believe that says 7 halves, right? Okay, let's double check everything here. So we found the slope by doing the difference in the y's, which is we went 1 up and we went 2 to the right, so that's 1 over 2, 1/2. That goes in here. Plug in either one of the points in here. You know, one way we could check it is to be sure that it actually goes through both points. So let's try 1/4. This should give us a 4 for y. Well, 4 for y. Let's see if this is true. 1/2 plus 7 halves is 8 halves. 8 halves is 4. So that checks. And so it definitely goes through 1/4. Let's see if it goes through 3/5. So 5 for y right here. Let's try that again. 5 for y, and what was it for x? 3. So that's 3 halves plus 7 halves is 10 halves. 10 halves, 10 divided by 2 is 5. So that checks there. So it definitely goes through both of them. So we definitely check that one. Okay, horizontal and vertical lines. A horizontal line straight across sideways is, well, first of all, this is going to go through -6, -7. There's a point there, and we want a horizontal and vertical lines through that point. Well, a horizontal line is going to be y equals whatever the y is there, -7, and the vertical line is going to be x equals whatever the x is, -6. So x, let's see, horizontal will be y equals, so that's this one, B, and the vertical one is x equals whatever the x coordinate is, -6, that's also B. Decide if these lines are perpendicular or parallel or whatever. Okay. If they're parallel, the slope equals the original slope. And the slope, a perpendicular slope, the slope is -1 over the original slope. So we maybe need to find the slopes of these lines. 2x plus 4y equals 2. If we solve that for y, we get, let's see, 4y equals -2x plus 2. And then divide by 4, we get y equals -2/4, which is -1/2 x, and then plus 2/4, which is plus 1/2. So that's the first line. The second line is 4x plus 2y equals 7. Likewise, solve it for y. 2y equals -4x plus 7. Y equals -4 divided by 2 is -2x plus 7 halves. So here the slope is negative 2, and up here the slope is negative 1/2. Okay? So for them to be parallel, the slopes would have to be the same. So they're not parallel, and for them to be perpendicular, they're opposite reciprocals. Or in other words, if you take a slope and you multiply it by a slope of a perpendicular line, you should get negative 1. Okay? So these are neither parallel nor perpendicular in this case. And let's go back here to these. Let's see, this first one, the slope was negative 1/2. And the second one, the slope was negative 2. Okay. Alright, let's see what we got here. Okay. Slope-intercept form of an equation for a line passing through the given point parallel to the given line. So here there's two things. There's a given line and a desired line. Okay, the given line is 8x plus 9y equals 5. Subtract 8x from both sides and divide by 9 to get it into slope y-intercept form. So you see that the slope of the given line is negative 8/9. Now the desired line, well, if it's perpendicular, its slope would be 9/8. If it's parallel, its slope will be the same, 8/9. So now it's parallel in this case, so it's negative 8/9 would be the slope that we're looking for. And the desired line goes through the point 3, negative 9. That's not going to be on the given line, but it is on the desired line. Well, now we can just use y equals m x minus x1 plus y1, and so we get negative 8/9 x minus 3 plus negative 9. Okay, and so we get y equals negative 8/9. We have the equation of the line, but we want to do slope-intercept form, so we need to distribute here. Negative 8/9 times the x gives you negative 8/9 x. Two negatives multiply to get a positive. 3 times, well, actually the 3 and the 9 will cancel down to a 3. So that leaves an 8 on the top. Now this I'm going to multiply top and bottom by 3 to get a common denominator. So it's negative. We got a 3 on the bottom. 3 times 9 is 27. Okay, 27. Okay, so y equals negative 8/9 x. Okay, negative 27. Okay, they have a common denominator of 3. Negative 27 plus a positive 8 is negative 19. And there's our answer. Okay, so this is a parallel line. So this is the parallel line. So that's going to be this one right here, negative 8/9 x minus 19/3. Okay, now desired line 2, which is perpendicular. Okay, so now the slope is going to be the opposite of the reciprocal, so it'll be 9/8. That one's negative, this is positive. And this one still goes through. Okay, write a second equation for a line passing through the given point that's perpendicular. So it's still the same point here. Okay, and we should still use the same form like this. So this is still negative 9. And the x1 is 3. The slope this time is 9/8. So they want it in slope-intercept form, so distribute 9/8 x minus 27/8. You multiply by top and bottom by a here. So that's negative 72/8. That's negative 99/8 when we combine like terms there. So y equals 9/8 x minus 99/8. Be sure to use your little fraction thing over here. Okay, let's just check something here. Let's just check and make sure it does go through 3, -9. Make sure we didn't make any mistakes on that part. So we could check that. So this is 27/8 minus 99/8. Okay, that's 72, -72/8. 8 times 9 is 72, so that's -9. It's supposed to be -9. So it does go through there. Okay, and let's see if this one goes through. Let's check this one right here to make sure it goes through that point as well. Over here. So y equals -8/9 times 3 minus 19/3, and y should be -9 here. Let's see. The 3 cancels here down to a third, and we got a -8 on top. So that's -27 thirds, which sure enough is -9. So those both, this does go through that point, this does go through that point, and looks like the slopes are what we need. So I think we can feel confident about that. Let's go on. Alright, what do we have here? Okay, we've got an equation. Well, I can tell by looking at this that this is always true, because of the basically because of the associative property. I mean not the associative, the commutative property, that these two are equivalent. But if we try to solve this, look what happens if we try to add 4/9 x to both sides. That cancels out and we get 20 equals 20, or if we subtract 20, we get 0 equals 0. So at some point, whether it's here or even at the beginning, you're going to see that you've got an equation that's always true. So this is what's called an identity, or sometimes a tautology. It's something that's always true. And so the solution is all real numbers here. So another one to solve equation. Let's check this. Okay, 3y minus 7 equals 23 plus 3y. Subtract 3y from both sides here. Now we get -7 equals 23. This is a contradiction. That's never true. In other words, this equation is true when -7 equals 23, which is when? Never. So there's no solution to that one. So that's a contradiction. Okay, should be a simple one to solve here. 9 equals 4x minus 4. Add 4 to both sides of the equation. 13 equals 4x. Divide both sides by 4. We'll switch sides also. X equals 13/4. So it has a unique solution. So it's 1. The solution is x equals 13/4. Okay. Find the zero of the function. Now the zero of the function is when y is 0. And so the 0 is that coordinate. The ordered pair is the x-intercept. So a 0 or root of an equation is an x value that makes it 0. The x-intercept is actually not just a number, but rather an ordered pair. So we want to find this, and just looking here, looking at the scale, looks like these are 1 each. So it looks like it's at -2. 0 is where it crosses the x-axis. So the 0 is -2, and the x-intercept is an ordered pair, -2, 0. So be sure that you have an ordered pair for the x-intercept, but the x-coordinate of that is the root or 0 of that function. Now solving some inequalities. 9x minus 1 is greater than 6x plus 8. These solve exactly like equations, except that if we multiply or divide both sides by negative, we have to reverse the direction of the inequality. So I'm going to add negative 6x to both sides to get the x's eliminated on one side. And I'm going to eliminate the constants on the other side by adding 1 to both sides. So we get 3x is greater than 9. Divide by 3, x is greater than 3. So in set builder notation, the solution set is a set of all x such that, which is what this says right here, x is greater than 3. And that would, you find 3 and it would shade to the right. And I actually prefer a graph, once you find the 3, I prefer a graph where you do an open circle like that and shade to the right. But an alternative is the way they have it graphed like this, with an open like that, which is how you do it as an interval notation. You would say 3 to infinity, and notice you use the parentheses, so they use that version of graphing, so we'll use B for that. Okay, similar one here. 4 minus 4y less than or equal to 26y minus 9. We want to solve for y. So I'm going to add a negative 26y to both sides. It's going to give us a negative 30y on over here. We're going to add a negative 4 to both sides. That gives us negative 13. Now when I divide by a negative, it's going to reverse this to a greater than. So I get, well, the two negatives are going to cancel. I'm going to get 13 over 30. Okay, so that's somewhere between 0 and 1. And notice we'll be shading to the right, and because of the equal to here, we do include it. So in interval notation, this would be 13/30 to infinity. And so that must be, only one of those that makes sense would be this one here. And that looks about like that could be 13/30. Just a little beyond a third there. Okay, so let's see, what are our choices here? Greater than or equal to, and then fraction 13/30. Now, how could you check this? Let's go back and check this as well. So we can put in the 13/30 for y. And actually it should make this an equal if it checks. So let's see, I can cancel out a, let's see what I want to do here. Yeah, let me cancel out a 2 here. Okay, it makes that down to 15. And 2 times 13 is 26. So we have that. And let's see, let's just work on this side a minute. I need to get a common denominator of 15, so multiply by 15 over 15 here. So that's 4 times 15 is 60. 60 over 15 minus 26 over 15. Okay, common denominator 15. 60 minus 26, that's 34. Okay, now if it checks, I should get the same thing on the other side. Okay, nothing to cancel there. So common denominator is still 3. I need 26 times 13. Okay, let me just go over here. 26 times 13. 3 times 6 is 18. 3 times 2 is 6 plus that 1 is 7. And then 10 times 26 is 260. Add that together. That's 8, 13, 338. Now you need a common denominator, so I need to multiply top and bottom by 3. Oh, this doesn't look good. This is not checking. 300, 311 over 3. Okay, so it didn't check. So let's see, what did I do wrong? Okay, let's go back. 4 minus 4y, 26y minus 9. Okay, so I'm going to add a negative 26y to both sides. Negative 26 plus negative 4 is negative 30, so that's negative 30y. And I add negative 4 to both sides. Negative 30. Okay, so that looks like that's right. Must be maybe in my check. I made a mistake. So let's go down here. 13/30. 2 is 26. Okay, that looks right. 16, that looks right. That looks right. Okay. Oh, 13/30. There it is, right there. 13/30. Okay, good. There's our mistake. My mistake. You probably already caught it, didn't you? Okay, let's try this again. Alright, let's see, I'm going to cancel a 2 out, which means it leaves this 15, and I have 13 times 13. That's 39 and 130, 169. And then I need to get this, I need to multiply this by 15 over 15 to get a common denominator of 15. So I need 9 times 15, 45, and 90 is 135. 169 minus 135 is 34/15. Okay, good. That's checking now. Okay, good. That checked. So we've got the right boundary point. Now the question is, did we shade the right direction? And the easiest thing to do here is just do a test point. We know we have the right boundary point. Just take a test point on one side or the other. The easiest one to try is 0. So if I plug in 0 here, these things go away. I got 4 less than or equal to negative 9. Well, that's false, so you erase 0. So you erase this whole side, means you're going to be shading in the other side. So we have the correct direction as well. Okay, similar, 7 minus 8y less than or equal to 3y minus 3. Same kind of question. Add negative 3y to both sides and add negative 7 to both sides. And that gives us negative 11y less than or equal to negative 10. So y is less than or equal to 10/11. Okay. No, what did I forget to do? Okay, be careful. When I divide by negative, it switches direction. Okay, but we'll check that in the end anyway. So y is actually greater than or equal to 10/11. Okay, again, let's check it. So 7 minus 8 times 10/11 should actually equal 3 times 10/11 minus 3. So this is 7 minus 80/11 multiplied by 11 over 11. So 77/11 minus 80/11 is negative 3/11. And hopefully that's what we're going to get on the other side. Here we get 30/11 minus 3 multiplied by 11 over 11. So it's negative 33/11. Plus 30/11 is negative 3/11. So we have the right boundary point. Now, which one of these is it we're going to check? We check a point. Just check. Again, 0 is the easiest to check. So plug in 0 for y. These two terms go away. You get 7 less than negative 3 or equal to. That's false. So 0 would be the one where 0 is not shaded. So that means we're going to be shading to the right, which is exactly what this says. So we have the direction correct. 10/11 is almost 1. We're close to 1. We can shade the boundary point because that we're equal to. This one here, this one's a graph of y greater than 10/11. This is y greater than or equal to 10/11. This C is y less than 10/11, and D is y less than or equal to 10/11. We want B. Okay, a compound inequality, 7 less than or equal to x minus 6 less than or equal to 1. Add 6 to all three sides of this equation. Negative 1 less than or equal to x less than or equal to 7, and this is what you want. So in interval notation, this would go from negative 1 to 7, like that. And that's how they got it right here. And so it's going to be between negative 1 and 7, including the ends, which is that. Double check it. Put in negative 1. It'll make negative 1 should make one of the sides equal. See? So that works. And 7 should make the other side equal. That checks. And then double check that they've got the right part shaded. Notice that 0 is in this part in the middle, so try 0. That gives us a negative 6. Negative 7 is less than negative 6, which is less than 1. So that means you shade the inside part, not the outside parts. So that's correct. Okay, 5x less than or equal to negative 10, or x minus 8 is greater than 0. Back up to the last one just a minute. Well, just say this here, for example. This is saying negative 1 is less than or equal to x, and x is less than or equal to 7. That's a shorthand for this. It's an and. Both conditions have to be true. This one says that x makes either one of the conditions true, it's true. The whole statement is true, is either one is true. Possibly they could both be true at the same time, maybe, depending on what the statements are. Or maybe they can't be, but if x makes either one of them true, including maybe both, then it definitely makes the whole thing true. So here we're just dividing by 5. We get x is less than or equal to negative 2, or here we're adding 8, x greater than 8. So negative 2, we include that, and to the left, we don't include 8, but we include stuff to the right. So I think that's D here. Okay, and the interval is that you got to do it in two intervals. So this part right here is the interval from negative infinity to negative 2, including the negative 2, and this part over here is from 8 to infinity, not including the 8, and we're putting these together as one set. So the set operation is union. So that would be A. 36 of these guys. Okay. Another very simple, that's the one we just did. Next question. Okay. X plus 10 less or equal to negative 5/4, or x plus 10 greater than equal to 5/4. Well, let's see. Subtract 10 from both sides. Negative 10 minus 5/4. Okay, and I get a common denominator by multiplying top and bottom by 4 here. Negative 40/4 minus 5/4 is negative 45/4. Or add negative 10 to both sides. Negative 10 plus 5/4, so this is negative 40/4 plus 5/4. X is greater than or equal to negative 35/4. Okay, so less than negative 45/4. Okay, notice that's 11. This is in decimals. This would be x less than negative 11.25, or x is greater than or equal to negative. Let's see. 168.75. So it's to the left of here or to the right of this one. So we should find those things. It's going to be pointing, the arrows will be pointing out. So notice negative 11.25 is to the left of negative 8.75. We include either one of those, and we include to the left here or to the right here. So it's going to be that kind of an interval. Yeah, looks like this one's in the right place there. And so this is from negative infinity to negative 11 point, or negative 45 including union negative 35 to infinity. It looks like A is correct there. Again, you could check this. You could check to see that we have the right boundary points, and considering the numbers they have, it looks like we're probably right. But we could also check to see if we got the right part shaded by just doing a test point. So it looks like negative 10 is in this region in the middle. Try that. Negative 10 plus 10 is 0. 0 less than negative 5/4 is false. And this will give you 0 here. Greater than 5/4, that's also false. So 10 is not supposed to be shaded. So that eliminates, both of these are wrong. And we could test points in these outer regions like 0 here. 10 is less than negative 5/4, that's false. But 10 is greater than 5/4 is true. So that means 0 is included. Try something out here like negative 20. Negative 20 plus 10 is negative 10, which is less than negative 5/4. That's true. So this one's going to be shaded. So it's going to be one of these two, but notice the boundary points are included, so it's going to be C. Okay. So kind of do a little test points there. Okay, here we have an arithmetic sequence or linear function. A sub n, it was 3n minus 2, and we want to find the first 4 terms. Okay, and so a sub 1 is 3 times 1 minus 2, which is 3 minus 2 is 1. A sub 2 would be 3 times 2 minus 2, which is 6 minus 2 is 4, and so forth. But if you notice, the slope is 3. So once we found one term, the easy way to do this is we're just adding 3 each time we go down. So this would be 4, add 3 more is 7, add 3 more is 10, add 3 more is 13, and add 3 more is 16. Since this is arithmetic, since this is the form, this is a slope-intercept form, right? Y equals mx plus y sub 0, basically. So we know this is linear or arithmetic, and so we know it has a constant slope, and we know that slope is 3. That means our common difference is 3. Okay, except I got a little carried away here. Be careful here. The first 4 terms, that would be the 5th and 6th term. We need the 10th term now. So a sub 10 is 3 times 10 minus 2. 30 minus 2 is 28. So I need to be careful there. It jumped around a little bit on me there. Okay, and a sub 15, 3 times 15 minus 2, 30 minus 2, 45 minus 2 is 43. Okay, there we go. Here we have the sum from k equals 1 to 6 of 5k. Now, we can do this a couple of ways. There's only 6 terms here, so we could do 5 times 1 is 5, plus 5 times 2 is 10, plus 5 times 3, 5 times 4, 5 times 5, and 5 times 6, 5, 10, 15, 20, 25, and 30, and just add all those up. Okay, that's one way we can get it. Well, let me just do it that way. 105, I think. 30, 40, 30, 40, 50, 60, 80, 90, 105. So we can do it that way. But we also notice that this is arithmetic. So if it's arithmetic series, because we're adding it up, we can use this formula that says take the first term plus the last term, add them up, multiply by how many terms you have, divide by 2, that's going to be our sum. So if you notice, we have 6 things here. The first one is plug in the 1, 5 times 1 is 5. The last one, plug in 6, 5 times 6 is 30. And this should work as well. 6 divided by 2 is 3, and this is 3 times 5 is 30, 3 plus 5 is 35. 3 times 35, also 105. So 105 either way you go. Now, had that not been arithmetic, the only way we could have done it would have been the first way. Find the 13th term of an arithmetic sequence. Okay, so when they tell us it's arithmetic, that we find a common difference here, which is that's going up 8. Now, if it's arithmetic, it's got to be going up 8 every time. So let's just check that. Sure enough, 10, 18. Yeah, that works out. So we got the first several terms. So that's the slope, or common difference. Okay, and we know we can use the if it doesn't say otherwise, we assume the term numbers are 1, 2, 3, 4. There's not a 0th term unless they say there is. And so we know that a sub n is m. We can use the point slope formula, x minus 1 plus x1, or instead of x, maybe we'll call it a1. Or I'm sorry, we'll use n for the x. And then this is a 1 here. So the slope is 8, n minus 1 plus a1 negative 6. Now if you distribute, that's 8n minus 8 minus 6 is negative 14. You can write it that way. That would be, you'd have negative 14, so you add 8 and you get negative 6. That would be the 0th term. That's really not there, but that's what that one is. And so we have a formula. So I can use, I can use the version up here, I can use the version down here. Doesn't matter. If I want to find the 13th term, I can plug in either one of those now and work it out. So let's see what we got here. 8 times 13. 3 times 8 is 24. 8 times 1 is 8 plus 2 is 10. So that's 104 minus 14. I believe that's 90. What's another way we could do it? Well, we could actually go ahead and just work out all 13th terms one at a time, making sure that we're adding 8 each time. Okay. Okay, now they tell us this is arithmetic. Let's make sure that that works. If it's arithmetic, this should be going up by the same amount. It looks like it's going up by 0.06 here. Right? You add 0.06 to that, you get that. Or take this one minus that one, and you get this. That's the slope for the first two, the common difference, or the difference. Let's see if it's common. If we add 0.06 to this, yeah, we get that. So there's our common difference. Okay, so what it wants to know the term number that goes with the term of 1.66. Well, again, we need to find our formula. Again, our inputs are 1, 2, and 3. So we can do n minus 0.1. Oops, put the parentheses there. Like that. And then the m goes here. So this is m. It's like the point slope formula, like that. Instead of y, we're going to call it a sub n. Instead of x, we call it n. Our x1 our x1 is just 1. Sorry. Our x1 is just 1. Our y1 is 0.1. There we go. And the slope is 0.06. So we can leave it like that or distribute. I'm going to go ahead and just distribute 0.06x minus 0.06 plus 0.1. Okay. 0.10. So this is 0.06x plus 0.04. Okay, so maybe that's simpler, maybe not. Okay, and so now we want the term what's the term number? That's the x or the n. Let me make this an n instead of an x. It doesn't make any difference. That's the term number is n. We want to find the n when the a sub n is 1.66. So we put 1.66 here plus 0.04 here. First thing I'm going to do, I'm going to get rid of these decimals by multiplying both sides by 100. And when I do, it moves all the decimals 2 places to the right. And so when I distribute here, again, 2 places to the right, that's n plus 4. Okay, subtract 4 from both sides. 162 equals 6n. And so n is 162 over 6. Let's see, I'm going to divide a 2 out the top and bottom. That's 81 over 3. Oh, that works out nicely because 3 goes in 81 27 times. So it's the 27th term. Now, of course, n should be a whole number here if this is going to work out. So 27th term should be it. Some of the first 60 terms of this series, and they do tell us it's arithmetic, so this pattern should keep going. So we should find a common difference here. Let's see, it looks like it's 9. Yep, it's 9. So that's our slope. Slope is 9. Okay, so what's a formula for this? Okay, well, it's a sub n equals m n minus 1 plus a sub 1. Okay, so that's the point. That's just like saying y equals m x minus x1 plus y1. Point slope formula. So a sub n is, the m is 9, n minus 1, if we use the first term, a sub 1 is 25. You can leave it like that. You can back up 9 here to get a 0th term, which isn't really part of our sum, which would be 9 less would be, what would it be, 16. And notice that's what you get here. 9n minus 9 plus 25 is 6. This is 9n plus 16. We'd rather write it that way. We can. So either one of those, we can use either one to move forward. Okay. So let me call this, just because I'm going to use n for the number of terms here, let me call this k instead of n here. Okay, so we want to add up 60 terms of this. So n is 60, and we want to find a sub 60, what the last term is. 9 times 60 plus 16, that's 540 plus 16 is 556. Okay. Alright, so when we know the sum, if it's arithmetic, is first term plus last term times the number of terms divided by 2. Well, the number of terms was 60. The first term was 25, and we needed to find out the last term, which we just did, 556. 60 divided by 2 is 30. 25 plus 56. Let's see. 556 plus 25. Let me scoot over here. 556 plus 25. 581 times 30. 17430. Sum of all the multiples, okay, natural number multiples here, of 5 from 5 to 65. So it's 5 plus 10 plus 15 plus 20 all the way up to 65. Well, notice that this has a common difference or a slope of m. M is 5, so this is arithmetic. So we can use this formula. S is a first term plus last term, multiply by the number of terms, divide by 2. So the number of terms, okay, we need to figure out the number of terms. The first term we know is 5, the last term is 65, 2 is built in. So we just need to figure out how many terms this is. So let's go over to the side and do that. So what would this be? So this is 5 times 1, 5 times 2. So a sub k is just 5 times k. So a sub n is just 5 times n, and that's going to be 65. So you can see the n there is 13, I believe. Yeah, 13. So there's 13 terms here. 5 plus 65 is 70. 70 divided by 2 is 35. 35 times 13, 15, 9, 10, 350, 455. So it looks like that adds up to 455. Alright, next, solve this system of equations. They say do it by graphing. You can actually get the solution any method you want, since, I mean, who's going to know, because here we are, but we do want to graph this. Okay, I'm going to just do it by elimination real fast, because it looks like I can eliminate the x's real fast and get negative 3y equals 18. So here I'm getting y equals 6, negative 6, and maybe I can leave equation 1 alone and multiply equation this by negative 2 and get negative 6x plus 2y equals, let's see, multiply by negative 2, so negative 36, and the y's when we add together will cancel, and we get x equals 4. So it looks like xy should be 4, negative 6. So we'll see if that checks out here in just a minute. Okay, let's check it. Negative 3 times 4 minus 2 times negative 6 is supposed to be 0. That's plus 12. This is minus 12. Sure enough, that's 0. That one checks. Now let's check it in the other one. 3 times 4 minus a negative 6. That's supposed to be 18. This is plus 6. This is 12. That's 18. That checks. So we have the right number for sure. So it has a unique solution. Type in an ordered pair. So we click that for the ordered pair, and it's 4, and then click in the box, negative 6. Now we want to actually graph it as well. So, and we should see it going through that point on the graph. Now, to graph this, I can do it a couple of different ways. Notice this first one goes through 0, 0. So let's see. I want to graph this as 2 lines. So I want to click on the line tool, and one of them goes through the origin, and then let me go ahead and solve this for y. Just, I don't have to do it this way, but it's easiest probably. Negative 2y equals 3x. Y equals negative 3 halves x. So maybe if we let x be 2, y would be negative 3. So it should go through 2, negative 3. Okay, look at the scale here. 2, negative 3 should be about there. Should go through 4, negative 6. I can actually use that if I want. 4, negative 6. Okay. The next one also goes through 4, negative 6 if we did it right. Okay. And that's not the right answer. Let's see. Let's go over here and figure out what we need to do for this one. So for this one, say if we solve for y, negative y is negative 3x plus 18. y equals 3x minus 18. Okay, what about 0? Plug in x is 0, y is negative 18. Let's see if that fits on the window. Yeah, I can get that. So this one needs to come down here to 0, negative 18. And they both should go through the point 4, negative 6. So I believe that should be right. That should check out. Okay, x plus 2y equals 10. 2x plus 4y equals 48. You know what? Again, I'm just going to find this algebraically. It's pretty easy to do. Multiply the top one by, actually this is kind of interesting. Multiply the top one by, divide the bottom one by 2. So this says x plus 2y equals 10. And I divide by 2 here, I get x plus 2y equals 24. Well, clearly this has no solution, because the only time it would have a solution is when 10 equals 24. So these are going to be parallel lines when I graph them. So let's go ahead and solve, put them in solve for y. 2y equals negative x plus 10. Y equals negative 1/2 x plus 5. So that's a line with slope of negative 1/2, goes through 0, 5. Okay, and this one, let me just do it from here. 2y equals negative x plus 24. Y equals negative 1/2 x plus 12. So this goes through 0, 12. Both lines. So this one goes through 0, 5, which is there. Slope is negative 1/2. So write 1 down 1/2, or write 2 down 1. So let's see, that looks like I've got it to point 24. Does that work here? Yeah, 24 works on that one. And let's check another one. Looks like it's going through 10, 0. Is that right? Yeah, that's right. So that looks like we got that one graphed right. And this other one should be parallel. It goes through 0, 12. So we need another line. 0, 12. And it's also going to go the right 2 down 1. And it looks like that. Let's see. This looks like it goes through 16, 4. 16 times negative 1/2 is negative 8, plus 12 is 4. Yeah. So I believe we have it. And we see parallel lines, so there's no solution, no intersection point. Use elimination. Again, you can use any method you want. If you'd rather use substitution, I mean, how am I going to know when you work it? But I'm going to use elimination. That's the one I like the best, really. So I'm going to take the first equation and multiply by 3 and leave the second equation alone. So this is going to multiply by 3 is 15x plus 3y equals 0. Leave the second one alone. 7x minus 3y equals negative 22. When I do this and add them together, the y's cancel out. The right side is negative 22. On the left side, the y's cancel, and the x's is 22x. So divide by x. I divide by 22 to get x is negative 1. So I know x. And to I'll eliminate the x's to find y. So I'll multiply the top one by 7 times equation 1, and by negative 5 on the second equation. So 7 times the first one is 35x plus 7y equals 0. And multiply by negative 5 here, get negative 35x plus 15y equals positive 110. And this is 22y. So y is 110 over 22. I cancel 11 out. This is 10 over 2, and that's 5. So y is 5. So we get xy. Ordered pair is negative 1, 5. Let's check it. Okay, negative 1, 5. 5 times negative 1 plus 5 is supposed to be 0. That checks. Check it in the other one. Negative 1 and 5. Negative 1 here, so that's negative 7 minus 15, negative 22. It's supposed to be negative 22. So that also checks. So it does have a solution. It's a single ordered pair. Negative 1, 5. And if it has a single solution, it is consistent and independent. Consistent and independent. Okay, now we got three equations, three unknowns. I can use different ways. Let me show you one way. I can use a matrix method with the Gauss-Jordan. I can use just elimination, substitution, whatever. I'm going to use, now if I had my calculator, I'd probably set this up in a matrix and just do it that way. But no calculator, I'm probably just going to do this. I'm going to eliminate x's. I'm going to add equation 1 and equation 2 together. The x's eliminate, and we get 10y minus 2z equals 26. So there's one equation with y, and I used equation 1 and 2. So I need 1 and 3. I need to use equation 2 and also eliminate the x. So let's see if I use the first two equations, multiply equation 1 by negative 2, and get negative 2x minus 2y minus 2z equals negative 10. And I'm going to add to that equation 2. I have to use the one that I haven't used before. 2x plus 5y plus 2z equals 16. Now when I add these together, I get 3y. Look at that, the z's eliminated too. Equals 6. So we got a bonus there. We actually were able to figure out y from this. Normally you would still have x's, or normally still have y's and z's here, but we got lucky there, and we were able to eliminate y and z, or x and z, and so we only had y. So now we know y. At this point, normally you'd have a y and a z. You'd solve that system of two equations, eliminate either the y or the z, find that out, and then go back and substitute. So now we actually know y. So now I can go back into this equation, put that y in, and solve for z. Alright, negative 2z equals 6, so z equals negative 3. So now I know z as well. Go back to any one of the equations, x plus y plus z equals 5, for example. Plug in the y and the z that we know, and this will allow us to solve for the x. X is 6. So we ended up with x, y, z is 6, 2, negative 3. Now we're going to check this because it's very easy to make a mistake. So first check it in this one. X plus y plus z is supposed to be 5. So 6 plus 2 minus 3 is supposed to be 5. That's 8 minus 3. That's 5 equals 5. So it checks in the first one. Okay, let's check it in the next one. 2x plus 5y plus 2z. And that's supposed to be 16. Alright, let's check it. 2 times 6 plus 5 times 2 plus 2 times negative 3. It's supposed to be 16. Let's see, this is 12 plus 10, that's 22. Minus 6 is 16. Alright, I'm feeling pretty good now because it's already checked twice. Let's check it the third one. Negative x plus 9y. Let's go here. Negative x plus 9y minus 3z equals 21. Okay, negative 6 plus 9 times 2 minus 3 times negative 3. It's supposed to be 21. Let's see. Negative 6 plus 18 plus 9. Negative 6 plus 9 is 3, plus 18 is 21. Checked in all three, we got it. 6, 2, negative 3. So it has a unique solution. 6, 2, and negative 3. Okay, you could have easily used a Gauss-Jordan method on that as well. Alright, so here we have A and B. We want 2A plus 3B. So that's 2 times 9953 plus 3 times negative 2, 7, 3, negative 9. 2 times this means you multiply 2 times each one of those. So that's 18, 18, 10, and 6. And 3 times each one of those, so that gives you negative 6, 21, 9, and negative 27. And then, of course, for this to be defined, they have to be exactly the same dimension. But if they are, you just add up all the corresponding entries. 8 plus negative 6 is 12. 18 plus 21 is 39. 10 plus 9 is 19. 6 plus negative 27 is negative 21. And sure enough, it's a 4 by 4, which they have here. 12, 39, 19, and negative 21. And we're almost to the end. A couple more. Okay, find the product if possible. Okay, so notice A is 2 by 2. B is 3 by 2. Okay? So these don't match. So AB is undefined. But BA is 3 by 2 and 2 by 2. These are the same. So the answer will be 3 by 2. BA is defined. What did they ask us to do? They asked us to do BA, and the answer will be 3 by 2. So we know it's A. We just got to figure out the numbers. Okay, so BA. So you write B first. And then A is here. Okay, and the way you do this is you do a row times a column. So, and that gives you first row times first column gives you first row, first column in your answer. So that's going to be 3. Let me make this bigger. Might need a little more room. So this is 3 times 4 plus 1 times 2. I'm going to go ahead and go over here. So that's 12 plus 2, which is 14. So we got the first one. First row, first column. Now to do the first row times the second column. That'll give you your first row. Did I do that right? 3 by 2 is this one, excuse me. 3 by 2. The first number is rows, the second number is columns. I had the wrong one marked. Okay. Okay, second row times second column. 3 times negative 4 plus 1 times 1. So going up here, that's 3 times negative 4 is negative 12. 1 times 1 is 1. Negative 12 plus 1 is negative 11. Okay. Now, second row times the second column. 0 times 4 plus negative 4. Is that negative? Make sure I can read my writing. Negative 4 times 2. So that's 0 minus 8 is negative 8. Second row times second column. 0 times negative 4 plus negative 4 times 1. That's 0 minus 4 is negative 4. Now, finally, third row, third column. 5 times 4 plus 5 times 2. So that's 20 plus 10 is 30. Second row times second column here. 5 times negative 4 plus 5 times 1. So that's negative 20 plus 5 is negative 15. So there's our answer. Okay, there we go. So it should be this one. 14 here, negative 11 here, negative 8 here, negative 4 here, 30, and negative 15. Whoops. Okay. I think I got them all. Worked. Let's submit the test. Let's see how I did. If there are any mistakes, I'll go back and fix them. Oh, little mistake on the very first problem. Let's go back and see if we can see what it is. Really? Did I not do 1? I did 12. Did I not get 1 on that one? My answer was 1. What did I do? Put in the check? Yeah. The check is 12. The answer was 1. I'd worked it right. I just didn't type in the right thing. So clearly that's obvious. The easiest one there I missed. Okay, but that should be a 1. Okay. That's the entire test.